So in previous examples, we were given two angles and a side. So we were given two angles in the side that is not included, and we were given two angles in the side that is included when we were asked to solve using the law of sines. In this case, side angle, so we're given two sides and an angle that is not included. Notice what this spells backwards. Okay, so notice what this spells backwards. When you notice that word spelled backwards, you know that you're going to have a pain. This is going to be a pain. If you think of this as a pain, right? A pain in the butt. This is a pain in the butt. When you think of this as being a pain in the butt, then you know that you've got three different things that could occur, and you have to figure out what's happening. So it's a problem-solving type of situation. Do I have no triangle, which means I can't solve the triangle at all because no triangle exists? Is there just one triangle, so there's only one solution? Or are there two different sets of triangles and solutions that could exist? It's true, that could happen. So let me show you an example. So I'm going to give you an example of the single solution. So we're given two sides and the angle between. Two sides and the angle between. And the information they're giving us is side A is 22 inches, side B is 12 inches, and angle A is 42 degrees. So remember, the first thing that I did was I drew the angle. So I'm going to try and draw a 42 degree angle right here. And I'm going to label it A. This is 42 degrees. Now, across from 42 degrees, I have 22 inches. But I don't know where 22 inches goes. Does 22 inches go here? Does it go straight down? Does it go out that way? Where's 22 inches? So I can't draw that one yet. However, I can say that side B, I'm going to call wherever this segment ends, I'm going to call that B. Now just know that B might have to keep going out, in which case I would have to move this letter B out here, or it might need to come in depending on my information here. So right now I'm just going to keep it here, but I'm going to have an eraser available in case I need to move it. So this is angle A, to the right is angle B, and I'm going to say that this length, that's going to be a fixed length, and that is angle C up there. So across from angle B, I'm going to have 12 inches. So this now represents this length, A to C, now represents 12 inches. So 22 inches is going to be almost twice that length. So for 22 inches to be drawn, it can't come in. That's not happening. It can't go straight down because that's not twice as long as that green segment. It's going to have to go out to the right. So I'm going to eyeball it. I'm going to say that that is twice two green segments, and it might not even be long enough, to be honest with you. It might need to go a little bit further out there, but I get the idea that I only have one triangle that I could draw here. There's only one triangle that I could possibly draw, and that's it. So that's kind of tricky. The beauty is that this is a video. You can go back and you can watch how I did this, because I do it the same way every time. So I'm not going to change things up and then all of a sudden be drawing that initial 42 degree angle somewhere else. I always go from left to right because that's how my brain works. Now that I have this set up and I have that idea in my mind, this is just one triangle. There's no other way to draw this. One triangle only. Now I can solve it. So I'm going to have 22A over the sine of angle A is equal to B, which is 12, over the sine of angle B equals, look at that, I've got a ratio where I know nothing. This is the first time this has happened. I'm getting a ratio where I don't know anything in the numerator and I don't have any value for the denominator. That means I'm going to have to use some information from when I solve for angle B to bring into that fraction. So I'll show you what I mean. I'm going to cross multiply. So I'm going to have 22 times the sine of angle B is equal to 12 times the sine of 42 degrees. I'm going to divide both sides by 22. And then the sine of angle B is equal to this numerical value right here. So this numerical value is a ratio. This is a ratio. In order to find angle B, I'm going to have to reverse the input and the output, which gives me an inverse sign. So I'm going to have the inverse sign of the ratio is equal to the angle B. And when I do that, I put that into my calculator. So those of you who don't have your calculator, you're not grabbing your calculator, you're not using your calculator, I'm waiting on you. Grab your calculator, put that in. Now, of course, I'm not going to wait that long, so you're going to press pause. There's lots of pressing pause here so that you can see if you've got the calculation ahead of me. So you know how to use your calculator. We've spent time doing that. Now we're looking to see, can you do this? Press pause and then reveal the answer. So here it comes. 24.1 degrees. So I'm getting approximately 24.1 degrees. We're going to round to the nearest tenth. It's going to tell you in the problem. So I apologize that this one did not. We're going to be rounding to the nearest tenth on these problems. 24.1 degrees is angle B, but you're going to store that value. Because on paper, it's 24.1, but in real life, it keeps going forever. So the real exact value is it goes on forever. Once we find angle B, we now have a second fraction that's complete. How does that help us with that third fraction? Well, remember our triangle angle sum theorem. So angle A plus angle B plus angle C is equal to 180 degrees. So we're going to use the 42 degrees plus the stored value, and we're going to subtract that from 180. And when we do that, we're going to get C is approximately, again, if you do not want to see this answer, you are pressing pause until you can get that into your calculator. 116.6 degrees. 116.6 degrees. And I think I'm a little dyslexic. I think that this was 21.4 degrees. So I apologize for that. This should have been 21.4. .4 degrees. I can imagine that that was bugging some people. That's okay. So we've got 21.4. I mean, it's not okay that it was bugging you. I apologize for that, but it's okay on my end that I made that mistake because I caught it. So we've got angle A, angle B, angle C. Now we're going to store this value. This value has to be stored. So you're not going to store it over angle B because you may need that calculation. So you're using different letters to store. Sometimes you store things as X. You can hit store alpha B, store alpha C. You can use that alpha button on your calculator. Once you store that value, you're going to be able to use your original ratio with this C over the sine of stored value C, C over the value of the sine of the stored value C, cross multiply, and we get, I'm going to write it down, little c is equal to 22 times the sine of stored value c. So I just put a c there because I literally store it in alpha c. So 22 sine of c divided by the sine of 42 degrees. And that is approximately 29.4 inches. So what did we solve for here? They gave us angle A. They gave us side A, right? So they gave us angle A was 42 degrees. They gave us side A. They did not give us angle B. So we'll do that. They did not give us angle C, and they did not give us little side C, but they gave us side B. It was 12. So we solved side C to be 29.4 inches. We solved angle C to be 116.6 degrees, and we solved angle B to be 21.4 degrees. We can check our answers by making sure that the angles add up to be 180 degrees. We can also check to see across from the largest side, we have the largest angle. So the largest side and the largest angle are paired up, and the smallest angle and the smallest side are also paired up. So our answer makes sense. So I'm going to box it. And that's an example of one solution. That's an example of one solution case. The example of the no solution case is coming up next. So in the next video, we'll do a no solution case.